Welcome. This video is on absolute value inequalities. So we have the absolute value and we have an inequality symbol, a less than, a greater than, a less than or equal to, or a greater than or equal to. Let's look at this inequality. The absolute value of x is less than 4. What values for x would satisfy this inequality? Well, it's got to be a number like 3, right? 3 would work. 3.5, 3.9, 0. How about negative numbers? Negative 2? Yes, because the absolute value of negative 2 would be positive 2, and that's less than 4. How about negative 6? No, not negative 6, because the absolute value of negative 6 is positive 6. And that would not be less than 4. So looking at a number line, where are the numbers that would satisfy this inequality? Yeah, it's the numbers between negative 4 and 4, right? Negative 3, negative 2, negative 1, negative 1.4, 3.78, etc. So all those numbers in the middle. Because it's a less than, 4 would not be included. So that's why we put parentheses whenever it's less than or greater than. If it had the line underneath that equals, if it was less than or equal to, then we could include 4. But 4 cannot be included because it's a less than symbol. 4, if we replace x with 4, absolute value of 4 would be 4, and 4 is not less than 4, right? So it goes just up to 4, 3.9999999. Same thing on the left. Negative 4 is not included. It gets close to negative 4, but not included. Negative 3.9999999. You get the idea? Okay, so can we write this with inequalities? Would this be an and or an or? Hopefully you've done inequalities with and or already. We would use an and here. We could write it as x is less than 4 and x is greater than negative 4. Notice that I wrote two inequalities. The first one is exactly the same. I just dropped the absolute values. The second one is almost the same. We dropped the absolute value, but there's actually two changes: the direction of the inequality and the sign of the number. So the first one, there were no changes. Second one, there were two changes. And we put an and in between. That will give us the region in the middle. In interval notation, we could write this as parentheses, negative 4, comma 4. So that's the interval notation of this solution. Okay, here's a property that we just used. The absolute value of ax plus b less than k gives us two inequalities. The first one is exactly the same, ax plus b less than k, and ax plus b greater than negative k. And we have to say that k is a positive number. So just like the last section, our value for k, that constant on the right-hand side, must be positive. Another way of doing this problem, I just want to note that, is that it's equivalent to the compound inequality with ax plus b in the middle, less than k on the right, and greater than negative k. So if you're going to a tutor or you're reading in a book and they do things a little bit different, it's still the same thing, it's just another way of writing it. I just chose to write it as two separate inequalities. The first one exactly the same, just drop the absolute values. The second one, two changes. Change the direction of the inequality and the sign of the number on the right. Okay, that's what this note is. The first one is exactly the same without the absolute value bars. The second, there's two changes. The direction of the inequality symbol and the negative sign inserted on the right-hand side. All right, let's do an example. We're going to graph the solution and write it in interval notation. So always pay attention to directions. The directions here, two things. We want to graph it and then write it in interval notation. Many times the teacher or on homework or using a computer program like MyMathLab, they'll want you to write the answer in interval notation. One of the reasons is it's because it's easy to write. It's easy to type in parentheses, a number, comma, another number, and then parentheses or brackets. That's easy to type into a computer. It's harder to graph a number line and show it being shaded in one direction or two directions. So interval notation is usually required on exams, on math programs where you have to type in the answer. Right, so enough of that. Two inequalities. The first one, no changes. The second one, two changes. So the first one, here's our first one, 2x minus 1 less than 5, and 2x minus 1 greater than negative 5. First one, no changes. Second one, two changes. The direction changes and the sign of the number on the right-hand side. It was positive 5, now it's negative 5. First one, no changes. Second one, two changes. Okay, now we'll solve each inequality. First, let's work on the one on the left. Add 1 to both sides. Then divide by 2. So we get x is less than 3. Now let's work on the one on the right. Add 1 to both sides. Then divide by 2. And we get x is greater than negative 2. And this is an and. So we want the numbers that are less than 3 and greater than negative 2. So let's graph it. So I put negative 2 and 3 on the number line. You don't have to put 0 in the middle. If you write negative 2 and 3, then everybody will know that 0 is between those numbers. So don't clutter the number line with a lot of numbers. Maybe we're dealing with numbers like 37 and negative 28. You don't want to see all the little tick marks between negative 28 and positive 37. It will look way too cluttery, too many numbers. So just put those two values on your number line. All right, so what numbers are less than 3 and greater than negative 2? Yes, it's right in the middle. Since it's greater than and less than, they're both parentheses at the ends. So when we write our answer, we use parentheses. Parentheses, negative 2, comma 3, close parentheses. Okay, let's look at the inequality where it's a greater than this time. Absolute value of x is greater than 4. What values for x would satisfy this inequality? Well, a number like 7 would work, right? 8, 5, anything to the right of 4. Not 4 again because it doesn't have the equals. So just after 4, 4.5, 4.1, 4.01. So do you see why we don't start at 5? Sometimes people will put 5 on the number line, but then you're excluding 4.5 and 4.1. So you still put 4 on the number line. How about a number in between -4 and 4, like 0? Would the absolute value of 0 be greater than 4? No, definitely not, right? How about numbers less than -4, like -5? The absolute value of -5 is +5, and that would be greater than 4. So numbers greater than 4 and numbers less than -4. We could write this as x is less than -4, or this would be an or this time, right? Not an and. X is greater than +4. Notice our two equations. Let's look at the one on the right. X is greater than 4. That's almost the same, right? As the original problem. The only difference is there's no absolute values. And on the one on the left, x is less than 4. Well, again, there's no absolute value bars. But there's two things that changed. The direction of the inequality changed, and the number in front of the sign in front of the number changed. So one of our inequalities, there's two changes. One of them, no changes. Very similar to the last example. The only difference is it's an or in between. So when it's got a greater than symbol, we're going to use an or in between the two inequalities, and when it's a less than symbol, we're going to use an and between the two inequalities. We'll write that again later, not to worry. In interval notation, this will be written as parentheses, negative infinity, comma, -4, close parentheses, union, so that U symbol is a union, parentheses, 4, comma, infinity, close parentheses. Okay, here's our property. It looks very similar to the last property. Absolute value of ax plus b greater than k is equivalent to ax plus b greater than k, or ax plus b less than -k, where k is a positive number. First inequality, no changes. Second inequality, 2 changes. The direction of the inequality symbol changes, and the sign of the constant changes. We start out with k being a positive number. We'll talk about later if k is a negative number, but not right now. So again, we made a note on our first inequality. It's exactly the same without the absolute value bars. On the second inequality, there's 2 changes. The direction of the inequality symbol, and a negative sign is inserted on the right-hand side. Let's do an example. Before we do that example, there's a note, almost forgot. The procedure for both is almost the same. If it's less than, use and. If it's greater, use or. And when you're graphing it, the graphing will remind you if you do forget if it's an and or an or. Okay, here's our example. The absolute value of 2x minus 7 greater than 13. Greater than 13. So 2 inequalities. The first one, no changes. The second one, 2 changes. So our first inequality, 2x minus 7 greater than 13. The second inequality, 2x minus 7 less than -13. Now we will solve each of them. Starting with the inequality on the left, add 7 to both sides. Remember, if I go too fast, and I'm sure I am, pause the video, work it out. Okay, so we have 2x is greater than 20, divide by 2, and that'll give us x is greater than 10. Now we'll move on to the right. Same steps, add 7 to both sides. That gives us 2x is less than negative 6. Then divide by 2. X is less than negative 3. We divided into a negative number, but we divided by a positive number, so we don't change the inequality symbol. It'll come up later, but don't forget that when you divide by a negative number, then you have to flip the inequality symbol. All right, let's put those on a number line and graph it. So we have negative 3 and 10 on a number line. The one on the right says x is greater than 10, so we'll graph from 10 to the right. The one on the left says x is less than negative 3, so we'll graph to the left of negative 3. On both of them, again, we will use parentheses because there's no equal sign. Now we'll write that in interval notation. So that would be from negative infinity to negative 3, in parentheses, union, 10 to infinity, that's also in parentheses. So here's a page of notes. It might get confusing to remember which one is which. So let's write this note. If the absolute value is less than a number, use the word and. And then I put in quotes, less than, less than, less than. Yeah, just kind of add a D there, right? Less than. And, yes, when you see the less than, it's almost there with a D. Just kind of put the D in yourself. Yeah, less than. And if the absolute value is greater than a number, you use or. Greater. Yes, bad spelling. Greater or. Greater or. Less than. Less than. Greater. Less than. Less than and greater or. There you go. Hopefully that helps. I know I sound stupid, but do whatever works, right? That's the deal. Okay, whenever we have a less than, it's always going to be between the two numbers. And whenever we have a greater, or it's always going to be going away from the two numbers. We will have two disjoint intervals. All right, let's move on. Here's our next example. Oh good, this one has an equals. The first two examples, they did not have equals. The absolute value of 3x minus 1 less than or equal to 1. Same directions. We're going to graph it and write it in interval notation. So, two inequalities. The first one, no changes. The second one, 2 changes. And again, it's a less than. So here's a note. We're going to rewrite the absolute value as two inequalities. Since the symbol is a less than, we're going to use and. And we also know that this graph will be an interval between the two numbers. Less than and it's going to be between two numbers. It's always good to know what it should look like before you've even done the steps. Okay, here's our two inequalities. First one, no changes. Second one, 2 changes. The direction of the inequality changed, and the sign in front of the number on the right-hand side has changed to a negative. Let's solve the one on the left first. Add 1 to both sides. Then divide by 3. So that gives us x is less than or equal to 2/3. The one on the right, add 1 to both sides. Three x is greater than or equal to 0. Don't worry that it's a 0. It's only a problem if 0 is in the denominator. So 0 divided by 3 is 0. So x is greater than or equal to 0. We'll put our numbers on a number line, 0 and 2/3. It's an and, so we know it's got to be between the two numbers. It has to be less than 2/3 and greater than or equal to 0. So just kind of graphically, if you remember and is the area that is overlapped. So it's going from 0 to the right and then from 2/3 to the left. Where does it overlap? It overlaps right in the middle between 0 and 2/3. So that will be our answer using brackets, 0, comma, 2/3. So when it has the equals, we use brackets, no equals, parentheses. If we're using infinity, infinity always has parentheses. Brackets are used to show that it includes that number and stops at that number. But when we have an infinity, there's no such last number. It's an idea that numbers will go on forever in that direction. So there is no stopping at that number. So therefore, anytime you have infinity, it's always parentheses, even if the other number is brackets. Okay, here's another example. The absolute value of 7 minus 2x less than or equal to 13. Less than or equal to, that's another and, right? Less than, and. Right. When is it or? When it's a greater. Greater is or. Okay, so we're going to write again the absolute value as two inequalities. Since it is a less than, we're going to use and. And we also know that the graph will be an interval between the two numbers. Okay, here we go. Two inequalities. Remember to pause the video if you want to work it out on your own. Here's our two inequalities. First one, no changes. Second one, 2 changes. We change the direction of the inequality and the sign of the number on the right. Work out the one on the left first. Subtract 7. So that leaves us with negative 2x is less than or equal to 6. Now we need to divide by negative 2. Yes, we are dividing by a negative number. Whenever you divide an inequality by a negative, you have to flip it. X is greater than or equal to negative 3. Okay, let's work on the one on the right. Same steps. Subtract 7 on both sides. Then divide by negative 2. So once again, we are dividing by a negative. That's right, we have to flip it. X is less than or equal to 10. Let's place those two numbers on a number line. We want numbers that are less than or equal to 10 and greater than or equal to negative 3. So it's the same idea. It's always going to be the region between the two numbers because that's where it overlaps. It goes from negative 3. The first inequality says from negative 3 to the right. The second equality says from 10 to the left. So numbers that satisfy both conditions, it's between negative 3 and 10, including, so again we will use brackets. Example 5, the absolute value of x minus 8 plus 3 less than or equal to 9. Okay, so before we could use our property, we have to have the absolute value by itself. This problem, it doesn't have that. We don't have the absolute value by itself. So we need to do that first. Here's a note about it. To use any of the properties given in this lesson, the absolute value must be by itself on the left-hand side before applying the property. Therefore, we will subtract 3 on both sides. This step must be done first, otherwise you will get an incorrect answer. Okay, that's true. Okay, so subtract 3 on both sides. That leaves us with the absolute value of x minus 8 less than or equal to 6. Now we could use our property. We could write it into 2 inequalities. The first one, no changes. The second one, 2 changes. This is a less than, so it's going to be an and. So x minus 8 less than or equal to 6, and x minus 8 greater than or equal to negative 6. Not too hard to solve this one. Add 8 on both sides on the left. That gives us x is less than or equal to 14. Add 8 on the right. That gives us x is greater than or equal to 2. So we want numbers that are less than 14, less than or equal to 14, and greater than or equal to 2. Again, that's right in the middle. So our answer is brackets 2, 14, close brackets. Okay, let's look at this. Absolute value of x minus 4 is less than negative 3. This is a negative number on the right. The absolute value less than a negative number. Does that seem right? The absolute value of a number is always greater than or equal to 0. Therefore, the absolute value cannot be less than a negative number. Our answer is no solution. So whenever you see less than a negative number, you can simply put no solution, no work to show. If you want to show the work, it's not needed, but we're going to do it anyways. It's probably not even proper, but why not? Don't tell anybody. Okay, so let's use a property. The first one, no changes. The second one, 2 changes. So on our first inequality, we drop the absolute value bars and we just rewrite it exactly the same. On the one on the right, we change the direction and change the sign of the number on the right. It's a less than, so we're going to use the word and. Okay, let's add 4 to both sides on both of them. That gives us x is less than 1 and x is greater than 7. It's got to be less than 1 and greater than 7. There are no numbers that are less than 1 and greater than 7. So it doesn't make sense. Still no solution. Again, I wouldn't do that. I just wanted to show you, if you don't believe the rule, you can still try to do the work and it won't make sense. Math is kind of cool, right? Yeah, I agree. Okay, so here's another one. This one's a little bit different. The absolute value of x plus 5 greater than a negative number. The absolute value, that gives us a positive. Actually, the smallest an absolute value could be is 0, right? But that's still greater than negative 3. So when is an absolute value greater than a negative number? Well, the absolute value will always be greater than a negative number. Therefore, the solution is all real numbers. And we'll write it this way, parentheses, negative infinity, comma, infinity. You could also use the symbol for all real numbers, which is a capital letter R with two vertical lines. But this is interval notation, so it depends on the directions. If they said write in interval notation, then we'd have to do this. In the directions on this problem, it doesn't say. So you could write interval notation or the symbol for all real numbers, or just the words all real numbers. Because there are no directions on this problem on how to write the answer. Okay, let's use a property anyways. Again, this is probably not proper, so don't tell anyone. Let's write two inequalities. The first one, no changes. The second one, two changes. And it's an or, greater or, greater or. Okay, subtract 5 on both sides of each inequality. That gives us x is greater than negative 8, or x is less than negative 2. So greater than negative 8, that's from negative 8 to the right, or less than negative 2, that's from negative 2 to the left, but it's an or, so we don't care about the intersection, we just want to graph whatever it says to graph. So here's in red lines, you could see that from negative 8 to infinity is the top line, and everything less than negative 2 to the left is the bottom line. That would be negative infinity comma negative 2. So our answer is the whole number line. The whole number line is being shaded. It's not an and. An and would only be the intersection of the two lines. But since it's an or, we're going to graph everything. So the whole number line is shaded. That's why it's negative infinity to infinity. Hope that made sense. All right, one more example. The absolute value of x minus 4 less than or equal to 0. Absolute value less than or equal to 0. Well, can it be less than 0? No, it can't be less than 0. Can it be equal to 0? Yes, it could. So the absolute value can never be less than 0. However, it can be equal to 0. So that's what we're going to work out. We're just going to set the inside equal to 0 without the absolute value bars. That's an easy equation to solve. Add 4 to both sides, and we get x equals 4. So this one only has a single number solution, 4. If we wanted to graph it, you would just write a number line, and then at 4, put a dot on 4, and that would be our answer for a graph. Okay, let's use the property to show the work. Again, don't tell anyone. The first inequality, we write exactly the same. The second one, we drop the bars, and we make two changes. We change the direction of the inequality, we flip it, and then you put a negative in front of the right-hand side. It's a less than, so we're going to put an and in between. Less than, and. So x minus 4 less than or equal to 0, that's the first one. No changes. The second one, x minus 4 greater than or equal to negative 0. That's our second inequality. Okay, so the first one on the left, add 4 to both sides, and that gives us x is less than or equal to 4. On the one on the right, we'll still add 4 to both sides. Negative 0 is still 0. So 0 plus 4 is 4. So we want to know what number is less than or equal to 4 and greater than or equal to 4. It's got to be less than or equal to 4 and greater than or equal to 4. Well, there's only one number that satisfies that condition, and that is 4. Okay, I'll see you here for the next video. Have a good day.